enclosures are similar to blocks in Objective-C and lambdas in other programming languages. The global and nested functions that you studied in the previous lesson are actually the special cases of closures. To understand closures, you need to understand function types that we discussed in the previous lesson, so brush up your memories before proceeding ahead. The closures can be best explained by using the sort function that is a part of Swift's standard library. The function type for the sort function is shown here. You may not understand a few things here. It suffices even if you understand that the function takes two parameters, as enclosed within the parentheses shown here, and returns an array to the caller. The first parameter is an array of elements. This represents the array whose elements are to be sorted. The second parameter is a function type that takes two parameters and returns a bool value. This function decides whether the first parameter value should appear before the second one and accordingly returns a true or false to the caller. The sort function itself returns a sorted array to the caller. With this small introduction to the sort function, let us apply it in a practical case. The code shown here uses the sort function to sort the elements of a given array. First, we define an array of few double-value elements. We will sort this array in an ascending order. For this, we will write a function called ascending that takes two double-value elements as parameters. If the first element is lesser in value than the second element, the function returns Boolean true to the caller. We will send this function type as a second parameter to the sort function. The sort function takes two parameters that we have created so far and returns a sorted array that is assigned to the variable called sorted numbers. The program now prints the elements of the sorted numbers array to verify that those are indeed sorted in ascending order. The second parameter that you have sent to sort function is said to be of closure type, and the function ascending is called a closure in Swift terminology. When you run this code, you will see the output shown here. As the ascending function body consists of just one single line of code, it is easier to write the sorting closure inline. This is done using closure expression syntax. I will now show you this syntax with a series of statements that keep on reducing the expression to make it short and more readable. We now provide the definition of sorting closure in the declaration of the second parameter of the sort function. Note that the value of the second parameter is enclosed within two curly braces. This parameter is a function type that takes two parameters f1 and f2 shown here, both of type double. The function returns a Boolean type. The in keyword here indicates the start of the closure's body. It also says that the definition of closure's parameters and the return type shown here has finished. The body itself consists of a single-line expression that returns a Boolean value based on the comparison of two double-value numbers. After executing this statement, if you print the contents of sorted numbers array, you would see the same output as in the earlier case. Now, let us start reducing this inline closure expression. This is a reduced expression. In this, we have removed the data types of input and output parameters as the compiler would infer it from the type of parameter that the sort function expects. In the next version, we remove the return keyword. The closure function body consists of only one single statement that returns the result of comparison of two double-value numbers. Thus, an explicit return statement is not required here. The compiler can infer this automatically. In this revision, we use the shorthand argument names. The values of the closures arguments are referred by the names $0, $1, $2, and so on. Thus, rather than using two external names such as F1 and F2, we can directly provide the comparison of the first two arguments to the closure function. We now do the further reduction by eliminating the two arguments. The overloaded less than operator is a function that compares the two operands and returns a boolean. As you have seen through this series of reductions, that inline closure expressions can reduce your code substantially and make it also more readable. If the closure expression is the last argument to the function, it may be written as a trailing closure. This is especially useful if the expression is long. I will now rewrite the call to our sort function using the trailing closure. Here, the closure expression is moved outside the list of function parameters. The parameter list consists of only one element. The second parameter, which is also the last one in the parameter list, is of closure type and is not included here. Rather, the closure expression is enclosed in curly braces that follows the function call. If the expression is sufficiently long, this can be very useful. I will present a more realistic example to illustrate this. Consider that you are required to print an English number in Hindi. As the example shows here, each digit in English is converted to its equivalent Hindi character, while printing the number in Hindi. So let us write a closure to achieve this goal. First, we write an array to provide the mappings for each English numeral to equivalent Hindi numeral in character format. Next, we define a set of numbers for testing. We now use the map function of the array class to convert our numbers. The map function takes a single argument of closure type. We define the closure here as an expression by opening a brace and writing the closure code within the two braces. Note that a call to the map method does not require an opening and closing parentheses. This is because the map function takes only one argument and that too is of closure type. Since we are providing the closure function inline, it is not mandatory to use the parentheses for the function call. The map function returns the mapping for each individual element of the numbers array. The kind of mapping itself is decided by your mapping closure. The assigned Hindi numbers constant will be an array having same size as numbers array, and each element of it will be a mapped equivalent of every element of numbers array. So now, let us look at the closure function itself. In the closure function, we first write its function type. Our closure function takes a single argument of integer type and returns a string. The argument number is declared as variable so that its value can be modified inside the function body. The in keyword now starts the function body. We create a variable for storing the output of mapping. We write a do-while loop to extract each digit of the given number. The mapping itself is done by simple array lookup. The function returns the map string. After all mappings are performed, the Hindi numbers array contains the map strings. We print this array on the console. When you run the program, you will see this output. Having seen how to write trailing closures, you will now study how a closure captures values from its enclosing context. As before, you will study this feature through a concrete programming example. Here, we define a function called monitor. The function takes two parameters. The first one is of type integer. The second one too is of type integer with external name threshold temperature. The function return type starts after this. The return is of function type. This function takes one input parameter of type integer and returns a boolean. Thus, calling monitor function in your program code would result in receiving a reference to another function that receives one integer parameter and returns a boolean. Within the function's body, we create a boolean variable. Next, we write a closure called alarm that receives an integer parameter and returns a boolean. Within the function's body, we check if the input parameter value is greater than threshold and the value of the boolean is alarm set. Note that both threshold and isAlarmSet variables are not defined in the context of alarm function. They are defined in the context of the enclosing function monitor. This is said to closure capturing values from its enclosing context. If both conditions are satisfied, we print a message to the user and set the boolean variable to true. Once again, note that the function captures the two variables index and isAlarmSet from its enclosing context. Finally, we return the value of the boolean variable to the caller. We now close the monitor function definition by return alarm, which is a function type matching the return type of the monitor function. To test the monitor function, we write a small code snippet shown here. We call monitor function with two parameters. The first one refers to the index of the monitor that we want to create. The second one sets the threshold temperature value for the created monitor. This function call returns a function type that is assigned to constant called monitor1. Now, using the obtained function reference, we call the function with input parameter value 30. Note that the monitor1 refers to a function that takes a single integer parameter and returns a boolean that would indicate whether the alarm for this monitor has been previously set by an earlier condition. If so, we print alarm already set message to the user. If not, we tell the user that the current temperature is below the set threshold value for this monitor. As the current temperature value is 30 and the set threshold is 40, the call to a function using reference monitor1 returns a false condition. And the program returns the output shown. Now add one more call to the function referenced by monitor1, this time setting the current temperature to 50. As this value is more than the set threshold of 40, the function returns true. When you run this snippet, the output would be as shown here. The first line of message is printed by the alarm function itself while setting the alarm. The second line is printed by the code shown here. Now, add one more call to monitor1, this time setting the current temperature value to 60. As the alarm has been previously set, the function returns true without printing the setting alarm message. When you run this snippet, you would see the output shown here. Note that only one line of message is printed. The function itself does not print any message on the console. Check out the monitor function code to satisfy yourself. What is important to us here is that the value of the boolean isAlarmSet is retained across 3 calls to the monitor1 function that we made here. Now, let us try by creating another instance of closure as shown next. The monitor2 now refers to another closure instance with index value of 2 and threshold set to 70. You can verify this by calling the closure using this new reference. This time the function call would return true, clearly indicating that this instance of closure is different than the earlier instance where the threshold was set to 40. You would now see the output shown here. Try adding one more call to monitor2, setting the current temperature value of 90, which is above the set threshold for this closure. You will now see this output. It is evident now that both closure instances are distinct and retain their own individual status. With this, I will now close this lesson on closures. Though closures provide a nice way of writing inline shortcode, it does require lots of thinking in developing efficient closures. In the next lesson, you would learn another important construct, and that is understanding structure type. Hope you like this module. Over the past several years of iOS development, we have deployed many apps in the App Store. Like this course, many of these apps are free to download. Do visit the URL mentioned here to download and try out these apps. Thank you for supporting our development. Now, as you have completed this module, you will definitely like to look up other modules in this course. Do visit the above URL to get links to all other modules in this course.